Hello and welcome to Algebra 2. We're doing solving equations that are in factored form and finding GCFs. Now for my classes, most of this is going to be review, but that is okay. We probably need it since it's been a while since we've seen this stuff. Alright, now let's start with solving in factored form. Now we're going to remember that if I took two numbers, we're going to pretend we're playing Wheel of Fortune here, but it's Math Nerd Wheel of Fortune. If I took two numbers and multiplied them together and I knew that the answer was 0, I knew if I were playing Math Nerd Wheel of Fortune, either this number had to be 0 or that number had to be 0, because any number times 0 is 0, and that's the only way I'm going to get 0 here for that answer using multiplication. So one of these two things has to be 0. So the same thing here, either this is 0 or that is 0 in order to make this true. So I'm going to set that first set of parentheses equal to 0, and I'm also going to set the second set of parentheses equal to 0, just like that. Then I'm going to solve each of these equations separately. So I'm adding 6 to both sides, and I get x equals 6. Over here I'm going to subtract 2 from each side and get x equals 2. So if I put a 6 into this equation, that would give me 6 minus 6, which is 0, times 6 plus 2, which is 8. So 0 times 8 is 0. If I plugged a 2 in here, that would give me 2 minus 6, which is negative 4. Negative 2 plus 2 is 0. So whatever times 0 is still going to give you 0. Nice, huh? Alright, we're going to do the same thing with this one. Doesn't matter how difficult it looks, we're just going to take each of these things, set them equal to 0. So 5x minus 6 equals 0, 3x plus. I added 6 to both sides. Then we've got the 5 touching the x. We don't want them touching each other because that's just gross. And then I've got 6 over 5. Some people like to put everything in decimal form. That's okay. If you do this in decimal form, this is just going to give us 1.2. So if you got 1.2, that's fantastic. Alright, then over here I'm going to subtract 4 from both sides. I have 3x equals negative 4. Don't forget the negative sign. Then divide by 3. This gives me x equals negative 4 over 3. Again, some people like to do decimal form. If you do, that's negative 1.3 repeating. And those are our two answers. Now we'll go to one that looks a little bit trickier. This one does not have a set of parentheses, but I'm still considering this its own separate box. So that 5x, I'm going to set that equal to 0. And then this set of parentheses, I'm going to set him equal to 0 as well. And then just like before, we're going to solve. So those two are touching. I'm going to divide by 5. So I got x equals 0. So if I put a 0 here, that would be 5 times 0, which is 0. And if I distribute the 0, everything would be 0. And then over here, just like I did before, solve this equation. And you know how to do this because you passed the first semester of algebra. So this gives me negative 3 over 7. And those are our two answers. Alright, let's move on to something that looks even trickier but really is not. Just like before, we're going to set each of these things equal to 0. Don't distribute through. A lot of people get excited because they see that you could do distribution there. Yes, you could, but that's going to do no good for you at all. It will make it more difficult for you to solve. So, since it's in factored form, the easiest thing to do, set both of them equal to 0 and solve it. So, just like before, we're going to divide by 3. We've got x squared equals 0. How do we cancel an x squared? We square root it. And the square root of 0 is 0. Normally, some of you know you would put a plus or minus here. If you don't know what I'm talking about, that's okay. We haven't hit that yet. But positive 0, negative 0, it's all the same thing. It's just 0. Here, just like the other one, we're going to add 8 and divide by 5. This gives us 8 over 5, or some of you in decimal form like 1.6. Okay, pretty easy, right? Now, on we go to factoring out the GCF. Remember way back to when we were doing this before our mandatory long by 3? 15 is 3 by 5. And next, all we do is figure out what do these two have in common. And we write all those things down. These have a 3 in common, and that's it, because that has a 2, but that does not. That has a 5, but that does not. So our GCF is 3. Do they have any letters in common? No, because 15 does not have any letters. So our GCF is 3. So what I do is I'm going to take each of these and divide them by 3, factor out that 3 to the outside right here. Then you'll remember that I always do my numbers first. So 6 divided by 3 is 2. Negative 15 divided by 3 is negative 5. Then I go back and do my letters. This one was a pretty easy one. We didn't have to worry about exponents. We're just plopping down our x. Alright, and there it is in factored form. Now if this had been equal to 0, I would set each of those equal to 0 and solve. Since there's no equal to 0, all I'm doing is factoring out that GCF. Alright, this one a little trickier. I see that I've got no exponent there, so of course I'm going to put a 1. Now I'm going to do factor trees for 16, 24, and 48. 16 we know is 4 by 4, and 4 is 2 by 2. 24, and again I could have done 8 times 2. You have many options here, but you just want to pick, I always try to pick numbers that are close together. In this case 4 by 6 gives me 24. I could have done 2 by 12, but that's going to mean my tree is going to be longer, it's going to take me more steps. So 4 is 2 by 2, 6 is 2 by 3, and that's it. Remember, an easy way to check that you've done this correctly is to take 2 by 2 by 2 by 3 and make sure that it does indeed equal 24. If it does, you did it right. Alright, let's work on 48. 48 is 4 by 12. 4 is 2 by 2. 12 is 4 by 3, and unfortunately I can still go because I can reduce the 4 to 2 by 2. Remember to copy everything down so that all these numbers are together on the bottom line, so that if you multiply them all together it would equal that top number 48. Next I'm going to circle whatever they have in common. So this one has a 2, that has a 2, and that has a 2. So I copy that 2. Next, it looks like they have another 2 in common. So I circle each of those and write it down. Next, they still have another 2 in common, so I circle all of those and write it down. That one has a 2, that one has a 2, but that one has a 3 and no 2s. That one has a 3, that one has a 3, but that one has no 3s. So now they have nothing else in common as far as the numbers are concerned. So that I know part of my GCF is 8. However, I've not looked yet at my letters. So looking at my letters, I have x cubed, x squared, and x to the first power. Remember, I'm always going to take the smallest exponent because that's the most that they could possibly have in common. In this case, the smallest exponent is 1. So this is going to be 8x to the first power. That's my GCF. So each of these numbers will get divided by 8x to the first power. And so what that does is I'm bringing my 8x to the first power outside. If you don't want to put that 1 there, it's not a big deal. And now I'm going to divide. So I have 16 divided by 8. That gives me the 2. Negative 24 divided by 8 gives me negative 3. And 48 divided by 8 gives me positive 6. Next, I'm going to go back and do my exponents. We know that big numbers, when they're divided, well, they divide. But the exponents, when the bases are divided, they're going to subtract. So that's why I'm doing them in a different order. I'm doing just the x's together so that I don't get confused. I don't have to switch back and forth between dividing and subtracting. So now all I'm going to do is subtract. 3 minus 1 gives me 2. Here I have 2 minus 1, that gives me 1. If I want to put the 1 there, I can. It doesn't have to be there. And here I've got 1 minus 1, which is 0, because those x's cancel. So this is it. It's 8x times the quantity of 2x squared minus 3x plus 6. And we're finished factoring out that GCF. Let's do another one. Hey, if you want to, you could just hit pause right now, try it out, and then see if we match. Otherwise, just play along. Here's 24, 48, and 54. Now, I'm trying to give you really big numbers that have a lot of factors that are difficult, so that when you get to easier ones, it'll be easier. All right, 24 is 4 by 6, which is 2 by 2 by 2 by 3. 48, let's do 6 times 8. And 6 is 2 by 3. 8, I cheat a little bit with the 8s, you know. I know that 8 is 2, 2, 2. 54, I'm going to do 9 times 6 is 54. That gives me 3, 3, 3, and 2. Okay, now I'm ready. Let's see what they have in common. So this one has a 2, that one has a 2, and that one has a 2. Now that's the only 2 that this one has, so they don't have any more 2's in common. But I do have a 3, and a 3, so I'm going to take out a 3. That one doesn't have any more 3's, so they don't have 3's in common, and those are the only numbers I see, so that's going to be my GCF. Or at least the numerical part of it. Now I have 2 different letters in this. I notice that my smallest exponent for the x's is 3, so this is going to be x cubed. Now I also have a y. This is y to the first power. What's y's exponent here? Well, you don't see a y, so because you don't see it, that's the same as y to the 0 power. So we're really not even going to worry about the y because there's no y's here to put. So it's just 6x cubed, and that's all. So I'm going to divide just like before. Divide each of these by whatever the GCF is. In this case, it's 6x cubed. And I'm going to take that out. Now, divide each of the numbers. So 24 divided by 6 gives me 4. 48 divided by 6 gives me negative 8. 54 divided by 6 gives me 9. Now I'm going to go back and do the exponents, subtracting them. 5 minus 3 gives me 2. 4 minus 3 gives me 1. 3 and 3, I subtract those, that gives me 0, so they completely cancel. But look, this y is here, and there's nothing to divide it by, so I'm just copying it down. If you want to put the 1, that's great. If not, I don't care. All right, there's our final answer. Finally, we're going to factor out the GCF and then solve. So like I said in the very first example, if this had equals 0 at the end, I would go ahead and solve it. This one does, so let's solve. So 36 and 24. Now, I know that I could actually go ahead and solve this equation by doing plus 24 and divide by 36. I'm just showing you a different way to do it so that we get more complicated stuff like x squared, you'll be okay. All right, 36 is 6 by 6, which is 2 by 3 by 2 by 3. 24 is 4 by 6, which is 2 by 2 by 2 by 3. What do these guys have in common? Well, I see a 2 and I see a 3. And I see another 2. So it looks like my GCF is going to be 12. Now, I notice that there's an x here, there's no x here, so they don't have any x's in common, so the 12 by itself is going to be my GCF. Therefore, I'm going to divide both of these by 12. Factoring out a 12 leaves me with 3 here minus 2 here. This one has an x, I copy it down. This one does not, so it's finished. Now, just like we did before, I'm going to set each of these, we're going to consider them boxes, each of these boxes equal to 0. So I have 12 equals 0, and then 3x minus 2 equals 0. Now, does it make any sense that that 12 equals 0? No, it makes no sense that 12 equals 0. It isn't equal to 0 ever. That's not even possible. So I'm going to cross that out. 12 cannot equal 0. Now over here, I'm going to solve for x. So I'm going to add 2 to both sides and get 3x equals 2. Divide both sides by 3, and I get 2/3. And that's my answer. Now, again, if you had done like a normal equation, whoops, let's pretend we weren't doing a factoring lesson. So if we were way back in the first semester, I would have added 24 to both sides. Just doing this to show you that it works. Those would cancel. I'd get 36x equals 24. I would divide by 36. And I would get 24 over 36, which, if you reduce that in your calculator or in your brain, would be 2/3. So this is just a different way to get the same answer. Now, will you always be able to solve it like this? No, definitely not. Some of these are going to have x squareds, x cubes, or crazier stuff than that, which we could not solve with equations because they're not linear. So therefore, we're going to have to do the factoring. This was just an easy example just to show you how. Let's go on to this one. Now again, we don't know how to solve this way back in first semester, but we do now. We have to find the GCF. So I have 20 and 8. Let's go ahead and factor those down. That's a 4 times 5, which is 2 by 2 by 5. 8, you know I kind of cheat on the 8. I know that 8 is 2 by 2 by 2. Now that I have those, I'm going to see what they have in common. So I have a 2 and a 2, and I have another 2 and another 2. It looks like 4 is part of my GCF. However, in addition to that, I'm going to look at my smallest exponent. My smallest exponent for x was 2, so this is 4x squared. So I'm going to take each of these and divide them by 4x squared. After doing that, I put 4x squared on the outside. Don't forget your equals 0. And let's divide. 20 divided by 4 gives me 5. 8 divided by 4, it's negative, gives me -2. Subtract your exponents, that gives me 1. Subtract your exponents, that gives me 0 because the x's cancel. Now, just like before, we're going to set each of these boxes, this one and this one, equal to 0. I know my drawing's beautiful, isn't it? So I've got 4x squared equals 0, and 5x minus 2 equals 0. Then we're going to solve each of these. So I divide by 4, square root both sides, and you get x equals 0 here. Over here we'll add 2, divide by 5, and we get 2/5, or 0.4. And that's it. That's my answer. Again, if you want to, you can hit the pause button and do this on your own and make sure that we match. Otherwise, just play along with us. Here I have 64 and 24 as my two numbers. This is 8 by 8, which is 2, 2, 2, and 2, 2, 2. 24 is 6 by 4, which is 3, 2, and 2, 2. Then we're going to circle what they have in common. I'm going to do it all at once. I see that we have 3 2's in common. So that is 8 for my GCF without the letter. So looking at the variables, I have a 2 here, I have a 1 here, so my smallest exponent is 1. So my GCF is 8x to the first power. X to the first power goes on the outside, then I'm going to set the whole thing equal to 0. Divide them, that gives me 8. Divide those, that gives me -3. With our x's, I'm going to subtract my exponents. 2 minus 1 gives me 1. 1 minus 1 gives me 0 because the x's cancel. Next, set each thing equal to 0, so I have this 8x on the outside equal to 0, and this 8x minus 3 equals 0. and then solve. Here I'm going to divide by 8. Over here I'm going to add 3. And then divide by 8. Done. Well, sadly, that's all the time we have for today. I hope you have enjoyed GCF factoring, solve by factoring, and factoring out the GCF in order to solve. If you have any questions, you know exactly where to find me. You know what my email address is, and you know what the assignments are. Everything is in Canvas. If you need anything, go ahead, send me an email, and hopefully I'll see you again soon.